Good morning again, everybody. I'm going to basically be talking about this paper that we published in April. I've got 17 co-authors, including Dave Carl, head director of the Center for Microbial Oceanography Research and Education here in SOEST, and also Mike Cooney, who is an engineer in the Hawaii Natural Energy Institute in SOEST. The co-authors include 2 National Academy Science members, lawyers, indigenous representatives from both the continent and the Pacific Islands and Hawaii, Southern Hemisphere folks, Northern Hemisphere folks, artists, and scientists. And the paper is a call to recognize what is now being called a polycrisis. It basically discusses the intersection of 5 global emergencies: climate change, disease, pollution, biodiversity loss, and social inequality. And it describes how these are interwoven, how they magnify each other at times, and investigates a potential cause of these, which is fundamentally our economic model, which is based on profit accumulation, wealth accumulation, and engenders a feeling of privilege. The wealthier you get, the more you feel privileged. And this economic model is strip mining our planet of critical resources that we need to survive. We only have one Earth. No one's coming to rescue us. The roots of this go back to 500 years of colonialism, where one community exerted its will on another community and developed the concept of privilege and right. And the end of the paper calls for a cultural change, swapping out our economic model of profit and privilege for one that is truly centered on sustainability. And that if we don't achieve this, we are running up against the limits of this planet to continue to provide for us a safe haven. So I'm going to dissect the paper, talk about climate change, of course, heat, food and water problems, biodiversity loss, disease, social inequality, and propose that we are in the midst of a sustainability transition. I'm sure, considering all the scientists that are in the room here, you're very well aware of the rise in temperature, especially last year, 2023, we set a new record for global surface temperature, just below 1.5 degrees Celsius. Climate change could reduce global economic activity by up to 14% just by mid-century and displace over 1 billion people as climate refugees. We are on the very cusp of a global crisis with multiple faces. And this is the carbon dioxide record from Mauna Loa, begun in the late 1950s. 79% of anthropogenic global warming is caused by carbon dioxide. It has a longer lifetime than some of the other greenhouse gases, and so that's why CO2 is the focus of most of our mitigation work. When we first began measuring CO2, it was accumulating at a rate of less than 1 part per million per year. But in the last decade, it's accumulated at an average of 2.4 parts per million per year. So it is accelerating. And last year, the CO2 growth rate was 3.4 parts per million, 86% above the previous year and the highest in recorded history. This, given that we have spent 2 decades earnestly attempting to replace our fossil fuel energy systems with clean energy systems. 40% of the CO2 we emit today will still be in the atmosphere in a century. 20% could still be there after 1,000 years. Recognizing the problems with climate change, the United Nations has put together an organization called the UN Framework Convention on Climate Change. They hold annual meetings called Conferences of Parties. COP29 is taking place right now in Baku, Azerbaijan. And in the COP in Paris in 2015, the world's nations agreed to cut their greenhouse gas emissions sufficient to stop global warming at 2 degrees Celsius. And with the agreement on this language, the Pacific Island nations, accompanied by Caribbean nations, walked out of the conference, refusing to sign this language, saying that 2 degrees Celsius was a death warrant. Britain and Australia soon joined them. And so additional language was added that all nations would pursue efforts to end warming before reaching 1.5 degrees Celsius, and 1.5 to stay alive became the new rule of thumb. 1.5 degrees, we're now hearing, needs to be a multiple year threshold that we do not duck down below again. So people are saying, well, it needs to be 1.5 or above year after year for probably a decade, even though we almost touched it last year, and most likely we're going to exceed 1.5 this year. So let's ask the question, how are we doing on achieving these goals? On the bottom axis is time. On the vertical axis is billions of tons of CO2 emissions per year. And this is the record of CO2 emissions leading up to 2020. 2019 was the record of CO2 emissions, the record high. We then entered the COVID pandemic and the global economy essentially shut down. CO2 emissions fell 5.4%, but by 2021, with the emergence of a vaccine and stimulus funding released from the world's governments to rev back up our economies, we saw a 6.3% increase in CO2 emissions. In 2022, another 1.2% increase, another 1.3% increase, and last year, an 0.8% increase. So we're going in the wrong direction. We have to lower CO2 emissions to stop global warming, and this is the pathway to follow, where by mid-century, any additional emissions are met by sequestration of some sort. So we have what's known as a net zero situation. But when you add up all the promises, the pledges of the world's nations and their policies and investments and how they will be replacing dirty fossil fuel energy with clean renewable energy, it actually takes us on a pathway to 2.3 degrees Celsius before the end of the century. However, if you actually look at the investments of the world's nations and their intentions, it puts us more on a pathway closer to 3 degrees Celsius. So there's a difference between pledges and policies, and this is called a gap. And the UNFCCC every year comes out with what's known as the gap report. And this is the gap report for this year. It comes out prior to each year's COP. Usually it's released in November. And it investigates this problem and brings us up to date on where we stand in terms of cutting our greenhouse gas emissions. So the latest gap report tells us to limit warming below 1.5 C, emissions must fall 40% by 2030. And to limit warming below 2 degrees C, emissions must fall 28%. Based on current commitments, emissions will only fall about 2.6%. Net zero pledges cover about 80% of global emissions, but most of these are hollow. They lack details and they lack implementing mechanisms. Limiting warming to 1.5 would require global emissions reductions of 9% per year. And recall that the global pandemic, we only dropped emissions a little over 5% in that 1 year. So this is not looking very good. What is the story? Well, this is the history of renewable energy from 1960 up to present day. Clustered in there is bioenergy, hydro, nuclear, wind, solar, and other forms of clean energy. And this is the history of fossil energy, oil, coal, and gas. So despite the fact that clean energy is now cheaper than fossil fuel energy, we are still failing to displace fossil fuel energy with clean sources. The United States energy system offers an example of what's happening here. So in a nutshell, even as renewables accelerate, so does the demand for new energy. This green arrow is clean energy deployment in the US, and this red arrow is dirty energy deployment in the US. AI data centers, the demand for more cooling energy, EVs and charging electric vehicles, and developing nations trying to develop new transportation systems, medical systems, education systems, all turning to fossil fuel or now nuclear energy in order to meet this rising demand for new forms of energy. Here we see CO2 emissions projected out to the end of the century. That's 2050, and you can see that this projection suggests that we may peak our CO2 emissions sometime this decade, but after that, they won't fall fast enough to take us to net zero, which would be this pathway, but instead they plateau throughout the century, and by the end of the century, have not fallen significantly and again, put us on a pathway to about 3 degrees Celsius. Governments plan to produce more than double the amount of fossil fuels in 2030 than would be consistent with stopping warming at 2 degrees Celsius. And there are additional problems. So every year, the CO2 emissions that are released, about 90% of them come from burning fossil fuel, and about 10% of them come from land use. Agriculture practices, which cause soil to oxidize and release CO2, deforestation, and other types of land use. And of these emissions, about 48% go into the atmosphere and partially trap heat that would otherwise escape to space. About 29% are drawn down by the terrestrial biome through photosynthesis largely, and 26% dissolve in the ocean, causing light acidification. But this critical component of terrestrial drawdown is beginning to fail. This is a screen grab of a number of papers that are in peer-reviewed scientific journals. Recall from your high school biology classes that photosynthesis removes CO2 from the air, but plants also respire, and respiration releases CO2 and water. Photosynthesis has a heat limit, a thermal limit, and beyond this, it sharply declines and respiration sharply increases. This is also known as leaf death. Carbon uptake by land plants is severely degraded under these conditions, and with continued emissions, models indicate that carbon uptake may be cut in half in as early as 2040. This effect is not accounted for in the UNFCCC national policies and projections. And this paper from Proceedings of National Academy of Sciences says that numerous studies suggest that a variety of ecosystems are operating at or near their thermal thresholds across the planet. And just last year, a study recently came out telling us that last year the amount of carbon absorbed by land has temporarily collapsed. In 2023, forest, plants, and soils as a net category absorbed almost no carbon. Let's talk about heat. This is just the front page of a couple of peer-reviewed papers. The emergence of heat and humidity too severe for human tolerance. Escalating global exposure to compound heat-humidity extremes. Business as usual will lead to super and ultra extreme heat waves. I like to think about the authors getting together and trying to find new adjectives to put in the title. And deadly heat waves projected in the densely populated agriculture regions of South Asia. Global heat wave risk over the past 3 decades has increased nearly 5-fold compared to the early 20th century. And this paper, in the Proceedings of the National Academy, called The Future of the Human Climate Niche. It shows that about 0.8% of the land surface is too hot for human existence today. These areas in black in the central Sahara Desert and also lining parts of the Red Sea. At 2.7 degrees Celsius, the modeling in this paper tells us that those regions will expand to become 1/5 of the planet's surface. Basically, everything in dark brown is the statistically significant result of this modeling. Models project that 1 billion individuals will be displaced for every additional 1 degree Celsius of global warming. And we're starting to see this play out, especially in the Northern Hemisphere summer. Here is the Central Valley of California, which produces 25% of the food for the United States, with temperatures this past summer reaching 126 degrees. Recognize that, of course, most of these workers are Hispanic and that there's a social equity issue here. They had to go from working during the day to working at night. They would shut down work at about 10 o'clock in the morning, and they would pick up their agriculture work again as the sun set and work through the night. Here's the entire nation of India this summer, south of the Himalaya Mountains, reaching 120 degrees Fahrenheit. These sorts of temperatures are driving communities to become air-conditioned communities. And climate change has already put about 9% of people, or 600 million, outside the livable zone. Climate change and expanding human needs have led to water and food impacts as well. In the United States, the continental United States, we are withdrawing 17% more aquifer fresh water than nature replaces, that recharge replenishes. In China, they're pulling out 22% more aquifer water than nature replaces every year. India, 52%. North Africa and the Middle East, they are destroying aquifers. By 2050, water demand is projected to grow by more than half while we are depleting these water resources. More than half of the world's food production will be at risk of failure within the next 25 years as a rapidly accelerating water crisis grips the planet. Demand for fresh water will outstrip supply by 40% by the end of this decade. 2.2 billion people currently live in areas where more than 80% of their water is depleted annually. All of these red areas. We live in a wealth bubble. We are protected from these direct negative impacts of climate change and resource depletion. But much of the world looks like this. Drought affected 1.8 billion people over the last 2 years, nearly 1/4 of all people on Earth, the vast majority of whom live in low and middle income countries. The deadliest single climate event in the global record was a drought in the year 2011 in Somalia that killed at least 250,000 people. Many don't realize that the 4 staple cereals of the human diet, soy, corn, wheat, and rice, begin to lose micronutrients as the amount of CO2 in the air rises. Food staples grown under higher CO2 have up to 13% less protein. It's replaced by carbohydrate, less zinc, vitamin B complex, and iron. Taking wheat as an example, wheat provides 1/5 of all human protein. The yield is threatened by wildfire, drought, flood, and higher CO2 levels. By 2050, the demand for wheat is projected to increase by 60%, and the yield is projected to decline by 25%. This, of course, is a recipe for food shortages, price spikes, bread riots, and other examples that we see playing out in certain communities today. 1 in 11 people worldwide went hungry last year, while 1 in 3 struggled to afford a healthy diet. By 2050, an additional 300 million people are projected to be malnourished, an additional 1.4 billion women and children likely to have iron deficiency. The natural world is also being sacrificed to insatiable human consumption. This paper, published in Science, talks about the pervasive human-driven decline of life on Earth, pointing to the need for transformative change. Since 1970, per capita consumption has increased by almost 60%, and global economic activity has grown 4-fold. Much of this growth has come at the expense of the natural world, which is increasingly managed to keep up with rising demands for food, energy, timber, paper, minerals, and more. A leading negative impact is beef agriculture. Since 1970, food crop production has increased 3-fold, and half of all agriculture expansion has come at the expense of forests. More than half of all deforestation is to raise cattle and the grain to feed them. 50% of habitable land and 2/3 of all freshwater use is used for food production. Cattle and the grain they eat use 1/3 of available land surface on this planet, 16% of all available fresh water, 1/3 of worldwide grain production goes to your cheeseburger. Producing beef generates 100 times more greenhouse gas than plant-based food. Accompanying this is the narrative of stolen lands. Over the past 5 centuries, European powers seized millions of acres from indigenous peoples across the globe. During decolonization, these lands were never returned. They passed straight into the hands of newly created countries and governments in all parts of the world outside of Europe. The new nations then have been selling rights to these lands for logging, mineral extraction, agriculture, and development. The result is deforestation, indigenous erasure, soil erosion, watershed pollution, and biodiversity loss. About 50% of the world's original forests have been eliminated. More than 38% of tree species worldwide are threatened with extinction. 86% of all land mammals are now livestock or humans by biomass. Of all birds, 70% are chickens or other forms of poultry. Less than 3% of Earth's land surface remains faunally intact. Human overconsumption, population growth, and intensive farming has shrunk global wildlife populations by over 70% in the past half-century. This biodiversity loss is linked to the spread of disease. We're now in the era of pandemics. There have been 335 new infectious diseases since 1970. 75% of these are zoonotic, meaning that they jump from the animal kingdom into human communities. Ebola, HIV, malaria, West Nile, anthrax, encephalitis, Zika, SARS, MERS, COVID-19, these are examples that you've all heard of. It's called a spillover event, when microbes carried by animals that cross into humans through contact. There are 4 venues for these spillover events largely. The first is habitat loss. Roughly 1/3 of new zoonotic diseases are directly attributed to deforestation and biodiversity loss. About 50% of the world's original forests have been eliminated, and globally we cause the net loss of about 10 billion trees per year. The second venue for spillover is vector expansion. The tropics are expanding. Mice, mosquitoes, ticks, deer, and other carriers are moving into human communities that had not had to deal with these diseases in the past. The third venue is extreme weather events, where microbes and humans come in contact. Typically, the major problem following a major earthquake or a flood is managing the disease that takes place for months thereafter. Human immune systems are compromised during these times. And the fourth venue is concentrated animal feeding operations, which are a breeding ground for virulent pathogens. We pack into industrial barns hundreds to thousands of chickens, dozens of cattle or pigs, and we are violating the laws of evolution here. Every time one of these animals dies, the body is removed and a new animal is put in place. So whatever virulent disease is causing this, whether it's a virus or a bacteria, it knows no natural bottlenecks. It constantly has new hosts, and this is different than nature. Nature, typically virulent microbes develop strains that are less malicious, but in a concentrated animal feeding operation, that's not the case. And so we have forms of avian flu that have over 69% fatality rate. And right now we have H1N5, a form of avian flu that is migrating around the planet. It has already killed millions of natural birds, and it has moved into the mammalian population from Antarctica up to the Arctic. It has killed bears, seals, and others. Overuse of medicines that are imported to keep these animals alive is partially behind the problem of bacterial resistance. So disease, environmental damage, climate change, and human inequality all form an amplifying feedback. Disadvantaged groups suffer disproportionately, resulting in greater inequality. The ratio of income between the income of the richest 10% on this planet and the poorest 10% is 25% wider than it would be in a world without global warming. The richest 10% of the global population owns over 3/4 of all global wealth. The poorest half of us owns just 2% of global wealth. This problem is rooted in human population growth on a planet that is not expanding, imperialism, which is when one community exerts its will on another community, and an extractive relationship with nature. These 5 crises of climate change, pollution, social inequality, biodiversity loss, and disease lead to polluted runoff, sewage, disease, wealth disparity, impoverishment, border conflict, defaunation, deforestation, pandemics, heat waves, wildfire, extreme weather, sea level rise, coral bleaching, record floods. We must urgently redefine our relationship with nature and each other as one of reciprocity, regeneration, and social justice. Last slide. We are in the midst of a sustainability transition that we must continue. Yes, we need to decrease carbon emissions. This is known as mitigation. We also need to adapt to climate impacts. But we need to do these two things always together and through a social justice lens focused on the most vulnerable among us. This is a social equity spin on mitigation and adaptation that the Assessment Report 6, the Intergovernmental Panel on Climate Change has introduced, called Climate Resilient Development. It includes increasing public health, affordable housing, education for all, water resources, overconsumption, disease, biodiversity loss, and pollution. Managing all of these. It's no longer just about climate change. It's about the mosaic of all of these problems and human communities' relationship to each other and this planet. We can't get carbon tunnel vision. And I'll end with a quote from Lord of the Rings that is not coming up. There it is. We don't choose the times we live in. The choice is how do we respond? So thank you very much.